Hi everyone, welcome back. And today we're going to be looking at sequences and series. And like probability and statistics, this is a topic that is not included in your textbook. So there are plenty of supplements that are available on your assignment sheet, and they include exercises for you to practice with also. So let's begin with a rather formal definition of exactly what a sequence is. So here's the formal definition of a sequence. It's best thought of as a function whose domain is either the entire set of positive integers, which will give us an infinite sequence, or a finite set of the positive integers, which gives us a finite sequence. And I'm pretty sure that doesn't make a lot of sense. So let's look at some examples and hopefully make sense of this. So this first sequence is a finite sequence, and there are only 4 terms in it, and there's no obvious pattern at all. And a lot of folks think, oh, there has to be a pattern for a sequence to be a sequence, but no, it's simply just 4 random numbers. We often give the terms in a sequence specific nomenclature, and so this is usually a sub 1, a sub 2, a sub 3, and the last term is a sub 4. Now please notice these are the numbers which are like numbers in a function. And this would be like a of 1, a of 2, a of 3, a of 4. So you can think of the domain as being 1, 2, 3, and 4, and the range is 3, pi, 17, 19 thirds. And once again, this is a finite sequence. So check this one out. This is infinite, and that's what these 3 dots here at the end mean. It just keeps on continuing. And this is one of my favorite sequences, and everybody gets a kick out of this one. This is known as the Fibonacci sequence. And the pattern, take a second and press pause and see if you can figure out what the pattern is. Did you get it? The first 2 terms are 1, and then every term after that is the sum of the 2 terms before it. So for example, 5 is equal to 2 and 3, and 13 is equal to 5 and 8. It's a very cool sequence. And this is infinite because we consider the terms never ending. Okay, let's look at another one. Okay, a lot of the SAT questions are all about discovering the pattern. So once again, take a look at this, press pause, and see if you can figure out what the pattern is. So you should be able to see that each term is obtained from the previous term by adding 2. And this is known as an arithmetic sequence. And it's going to be finite because we end with 25. So one of the interesting questions we might ask is, how many terms are there? And that's a question that you might want to think about. And let's look at one more type of sequence. Okay, so check this one out. And again, after a second or so, just press pause and see if you can figure out what the pattern is. And hopefully you can recognize that what we do is we're multiplying each term by 3 to get the next term. And a sequence which behaves like that is called geometric. So arithmetic is when we add the same thing to each term to get the next one. Geometric is when we're multiplying by the same thing to get the next term. And it's arithmetic and geometric sequences that are the ones that we're going to be studying the greatest. Okay, let's move along. Okay, so an arithmetic sequence is one in which we know what the first term is, and we know what we are adding in each case to get the next term. So if I write down the terms, the first term is a sub 1, and then a sub 1 plus d, and then a sub 1 plus 2d, and then a sub 1 plus 3d, and so on. But if I simply write down these terms in terms of their sequence order, first term is a sub 1, the next term is a sub 2, and then a sub 3, and then a sub 4, and so on. Now, do you see the pattern here? A sub 4, 3D, a sub 3, 2D. And so that gives us our first really big formula, that the nth term of an arithmetic sequence that has the first term a sub 1 and the difference d, can you guess? It's just going to be a sub 1 plus n minus 1 times d. All right, n minus 1, because this is the fourth term, and we're adding 3 d's. Third term, we're adding 2 d's. The nth term, so we add n minus 1 d's. So this is a big deal. It's one of our important formulas. It's worth remembering. So let's look at this example. Suppose we have the sequence 2, 5, 8, 11, and so on. Right? This is going to be an arithmetic sequence. It's arithmetic. The first term is equal to 2, and d, the common difference, is equal to 3. So suppose I want to know what the 12th term is. Well, the 12th term is simply going to be the first term plus 11 d's. And so the 12th term is going to be 35. All right? So that's some of the types of questions that you're going to be looking at. So we do the same thing with a geometric sequence. Right? The first term is a sub 1. The next term is going to be a sub 1 times some number, and that number is usually denoted by r. And then a sub 1 times r squared, a sub 1 times r cubed, and so on. But again, if we write these as just the terms, this is a 1, this is a 2, this is a 3, this is a 4, and hopefully you notice it's the same pattern as with arithmetic sequence. The fourth term is the first term times r to the third power, 1 less. The third term is a sub 1 times r to the 2, 1 less. And so that gives us the same type of formula. The nth term is equal to the first term times r to the n minus 1. And yes, that's the big formula for geometric sequence, telling us what the nth term is going to be. So let's look at an example here. And suppose we're looking at the sequence 3, 6, 12, 24, and so on. This is geometric. The first term is equal to 3, and r is equal to 2. And so, for example, if I want the 10th term, it's going to be a sub 1 times r to the 10 minus 1. And if you take out your trusty Inspire, you'll see that this is what you get. All right? Okay, let's move along. So now that we've gotten enough under our belt about sequences, we want to talk about series. And let's put out the formal definition of what a series is. So note, a series is defined in terms of a sequence, and a series is simply the sum of the terms of a sequence. So a sequence, remember, is a function, and a series is simply a sum. So in other words, a series is just going to be a number. Pretty simple. So let's look at, well, first of all, if we have a sequence, like a sub 1, a sub 2, a sub 3, and let's suppose it stops at a sub n, this is a sequence, then the series is just going to be a sub 1 plus a sub 2 plus a sub 3, adding up all the terms until we get to a sub n. So it's really easy to misspeak when we're talking about sequences and series. I'm always listening to what I said and trying to be sure that it was what I wanted to say. And I'm sure that I will make a mistake, perhaps, so be aware. But a sequence is a function. A series is the sum of the terms of a sequence. So a series is just a number. So check out this sequence. If we were going to give it a name, it would be an infinite arithmetic sequence. And so the series that it generates is 2 plus 5 plus 8 plus 11 plus 14 and so on. And it's clear that this is infinite. This sum does not exist. So let's look at what we get when we look at a finite arithmetic series. So just to make sure we get this straight, here's a finite arithmetic sequence. A sub 1, a sub 2, a sub 3, and so on. The associated finite arithmetic series is a sub 1 plus a sub 2 plus a sub 3 plus ... I guess I said finite, so I have to end it here. Right? So there we go. Now, let's look at an example. Suppose we're looking at 3, 5, 9, 15. That's my finite. Well, hold on. Stop for a sec. That's not an arithmetic sequence. So suppose we have 2, 5, 8, 11, 14. Then the corresponding series is going to be 2 plus 5 plus 8 plus 11 plus 14. So what we'd like to do is be able to come up with a formula for the sum of a finite arithmetic series. And so let's move along and do that. So we want the formula for the sum of a finite arithmetic series. In other words, we want a formula for S sub n, sum of n terms. First term is a sub 1. The next term is a sub 1 plus n minus 1 times d. And the last term is a sub 1 plus, oh, do you see the mistake? N minus 1 d. This shouldn't be n minus 1. This should just be a sub 1 plus d. That's my second term. Okay, so to figure out what this is, I'm going to write these terms backwards. So, in other words, this I'm going to write first. And so I have a sub 1 plus n minus 1 d. And then the term right before that would be a sub 1 plus n minus 2 d, and so on. And the first term here, the last term here, is the first term here, and so that's a sub 1. And now what I'm going to do is add these up, term by term. So watch what happens. On the left side, I'm going to get 2s sub n. Now look, let's try to organize this. When I add this chunk up, I get 2a sub 1 plus n minus 1 times d. And when I add these up, I'm going to get 2a sub 1 plus, well, n minus 2d plus 1d is also going to give me n minus 1d. And I keep adding like that. And my last term is also going to be 2a sub 1 plus n minus 1d. So notice each of these chunks right here is the same. 2a sub 1 plus n minus 1d. And how many of those do I have? Well, there's n terms, right? So there's n of those. So it's going to be n times 2a sub 1 plus n minus 1 times d. And remember, I'm looking for s sub n. So I simply divide by 2, and I get s sub n is equal to n over 2 times. Now what I'm going to do here is break this 2 times a sub 1 as a sub 1 plus another a sub 1 plus n minus 1d. Now if you notice, what we have right here is our expression for a sub n. I'll write it right below it. This much is just a sub n. So therefore my formula, let's pick a new pretty color. My formula for the sum of the first n terms of an arithmetic series is n over 2 times the sum of the first term plus the last term. And yes, indeed, that's a big deal. Let's put a box around it. Another big formula. So let's look at this. We want to get the sum of the first 20 terms of this arithmetic sequence. So what we want to do is use our formula that we just generated. So the sum of 20 terms is going to be 20 over 2 times the first term plus the last term, the 20th term. Well, I don't have what the 20th term is, but I know that the formula for any number term is this. And so my 20th term is simply going to be my first term plus 19 times d, and d in this case is 4. So if I go ahead and I compute that whole thing, I think I get 770. Okay? So that's the work that we do with arithmetic sequences, and especially arithmetic series. Let's move along to geometric series. Okay, so let's look at how we can get a formula for the sum of the first n terms of a geometric series. And here the trick is, we're going to look at this expression, and we're going to multiply both sides by r. So here's what we get. We get, I'm going to write it above, r times s sub n equals. Now, when I multiply a sub 1 times r, I get a sub 1 times r, and I write it above the corresponding term here. When I multiply a sub 1 times r by r, I get a sub 1 times r squared. And so do you see how this pattern is working? The term right before this, which would be a sub 1 times r to the n minus 2, is going to give me this. And finally, if I multiply a sub 1 times r to the n minus 1 by r, I get a sub 1 times r to the n. Now, what do you think I'm going to do with both sides? Yep, did I hear you say subtract? Very good. So when I subtract on the left, I get r times s sub n minus s sub n. When I subtract on the top, okay, so these are going to cancel, these are going to cancel, these are going to cancel, and the only thing that's going to be left will be this minus that. So I get a sub 1 times r to the n minus a sub 1. So remember, what I'm looking for is a formula for s sub n. So I look on the left and I factor s sub n out, and I get r minus 1. Over here I'll factor a sub 1 out, and I'll get r. I'll get r to the n minus 1. And then what I'll do is simply divide both sides by r minus 1, and I get s sub n is equal to a sub 1 times r to the n minus 1 over r minus 1. And that's more commonly written, if I multiply top and bottom by minus 1, as s sub 1 is equal to a sub 1 times 1 minus r to the n over 1 minus r. And there's my big formula. Sum of n terms of a geometric sequence. Okay, so here's an example that we can play with. And if we use our formula, s sub n is equal to a sub 1 times 1 minus r to the n all over 1 minus r. And if we use our trusty Inspire, this is what we should get. Okay, so pretty easy. And that's what happens when we're looking for the sum of a finite geometric series. A finite geometric series. Now, what about an infinite geometric series? Let's check that puppy out. Okay. So, when we're looking at an infinite geometric series, the big deal there is that it will converge. In other words, it will have a sum when the absolute value of r is less than 1. In other words, when r is between minus 1 and 1. And remember, converge means it will have a sum. Right? Now let's take a second and look here. Remember, our formula for n terms is a sub 1 times 1 minus r to the n over 1 minus r. Now, if r, the absolute value of r is less than 1, in other words, if r is some number between minus 1 and 1, then when n gets really big, this is going to get really, really small, and in fact, basically become 0. And so, what we can write is the sum of an infinite number of terms will equal, as long as r is less than 1, it'll just equal a sub 1 over 1 minus r. And that becomes a really simple formula. Right? So let's look at an example of that. Okay, so look at this one. This is an infinite geometric series. And what do we know about it? A sub 1 is 32, and r is equal to a half. And since 1/2 is between minus 1 and 1, this infinite geometric series will converge. And the sum of these infinite number of terms will just be a sub 1 over 1 minus r, which will turn out to equal 64. How easy is that? Okay, let's try one more. So this looks a little bit different, but what you'll notice on this is, yes, it's infinite, and yes, it's geometric. My first term is 81, and what does r equal? Kind of interesting, minus a third. So therefore, the sum of these infinite number of terms is going to equal the first term over 1 minus r, which is 81 over 4/3, which is 81 times 3/4, which is 243 over 4. And there we go. So let's just summarize all of this on the next page. Okay, so here's our big summary. We have arithmetic and geometric, sequences and series. And let's assume that for the arithmetic world, our first term is a sub 1, and the common difference is d. And similarly in the geometric world, first term a sub 1, and the multiplier, the common ratio, is r. So our formulas are that the nth term is equal to the first term plus n minus 1 d, and my formula for the sum of the first n terms is n over 2, let's get that right, n over 2 times a sub 1 plus a sub n, or we could also write that as n over 2 times a sub 1 plus what a sub n is, which is a sub 1 plus n minus 1 times d. Okay, so those are the formulas for the arithmetic world. In the geometric world, the nth term is equal to a sub 1 times r to the n minus 1, and the sum of the first n terms is equal to a sub 1 times 1 minus r to the n over 1 minus r, and finally the sum of an infinite number of terms will equal, as long as r is less than 1, just a sub 1 over 1 minus r. So there are a lot of formulas to remember in the world of sequences and series, and there's no getting around that, and so have fun memorizing them. Okie dokie, there you go. That was a long video, but hopefully it helps you understand the ideas behind arithmetic and geometric sequences and series. Bye-bye. Okay.